Hello, ladies and gentlemen. A very warm welcome to all of you. Welcome to my video lectures on science and technology. In today's lecture, I will draw parallels between the nuclear explosion, nuclear energy, and the oldest religion in the world, Hinduism, and the most powerful and the most famous Hindu god, Lord Krishna. J. Robert Oppenheimer, the father of atomic bomb and a theoretical physicist, after the first nuclear detonation, felt as if the world has bathed in a flash of light, only visible from the stars. After the explosion, in the words of Oppenheimer, few people laughed, few people cried, and few people were silent. During that time, Oppenheimer remembered the lines from the famous Indian epic Bhagavad Gita, where Lord Krishna persuades the Prince Arjun to follow his duty and says, "Now I have become death, the destroyer of the universe." In today's presentation, we will try to decode Oppenheimer's statement and understand the relevance of Lord Krishna and nuclear energy. So let's have a look at the roadmap to the presentation. So here's the roadmap to the presentation, and this is where we are heading. We will start with the Manhattan Project and have a look at the Trinity testing site. We will look at Oppenheimer's quote from Bhagavad Gita. We'll try to understand the nuclear energy and its mathematical analysis. We'll try to overview the physics of a nuclear bomb. And finally, we will try to analyze why did Oppenheimer quote from Bhagavad Gita. On 16 July 1945, the director of the Manhattan Project, a theoretical physicist, Dr. J. Robert Oppenheimer, decided to test the plutonium bomb at the Trinity testing site. And this is the actual footage from the site.
5, 4, 3, 2, 1.
In the dead silence of the morning, at 5:29:45 Mountain War time, the Jornada del Muerto was bathed in an intense flash of a light that man had only seen from the stars.
When the massive nuclear blast took place and its blazing light covered most of the sky, the following words from chapter 11, Sloka 12, came out spontaneously from Dr. Oppenheimer's lips, which means if the radiance of 1,000 suns were to burst at once in the sky, that would be the splendor of this mighty one. And this is what Dr. Oppenheimer had to say immediately after the explosion.
He knew the world would not be the same. Few people laughed. Few people cried. Most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that should do his duty, and to impress him, takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that one way or another.
Now, this sloka is taken from chapter 11 of the Hindu epic Bhagavad Gita, where Lord Krishna reveals his massive divine form to Prince. So let's have a quick overview of the physics behind nuclear energy. Nuclear energy is the energy in the nucleus or the core of the atom. The term atom comes from the Greek word meaning indivisible. It comes from the Greek word atomos, meaning indivisible. Atoms are in fact tiny units that make up all matter in the universe. Now, this is the structure of an atom, and you have the nucleus at the center, which is made up of protons and neutrons. And the energy that holds the dense nucleus, the energy that holds this dense nucleus, contains huge amount of power. And in fact, that is called the nuclear power. That nuclear power or that energy could be used to generate electricity in the nuclear power plant. This is the diagram of a nuclear power plant. Now, there are mainly two types of nuclear reactions, a fission reaction and a fusion reaction. In fusion reaction, two lighter nuclei combine or fuse together to form a heavier nuclei and release energy. Whereas in the fission reaction, a heavier nuclei splits into lighter nuclei with the release of energy. As you see, this is the fission reaction one. We are still working on the technology to generate electricity from a fusion reactor. Now, nuclear reactors use uranium pellets as a fuel to produce nuclear fission. In nuclear reactor, a neutron is fired to initiate a fission reaction. During the process, the heavier nuclei splits into lighter nuclei with the release of extra neutrons and tremendous amount of energy. Extra neutrons causes other uranium nuclei to split, initiating a chain reaction. This is where a chain reaction is formed, and this energy released during the chain reaction produces heat. The heat is used to heat the water, and the steam generated is used to run the turbine. The turbine drives the generators, and by the process of electromagnetic induction, electricity is generated. Now, this is a green and a clean energy, meaning no greenhouse gases are released. Now, let's try to have a mathematical analysis of nuclear fission reaction and try to analyze how much energy is released in a fission reaction. So here comes the reaction. You have uranium-238, and uranium-238 undergoes spontaneous fission. You see uranium-238, it undergoes spontaneous fission to produce strontium, xenon, and 3 neutron. Now, in order to calculate the energy, first we need to calculate the mass defect. So we will calculate the mass defect. And once we have the mass defect, we will use the famous Einstein equation equals to mc squared to calculate the amount of energy released. So you see, I'm trying to calculate the mass defect first. I'm using the concept of mass of the reactants minus the mass of the products. And I get the mass defect, which is approximately 0.183791 AMU. Now, you know that when we convert 1 AMU to the amount of energy released by the equation E equals to mc squared, you get 1 AMU is equivalent to 931.5 MeV, million electron volts of energy. So you could multiply 0.183791 with 931.5, and you would be getting 171.2 million electron volts of energy. So that much energy is released during this fission reaction. Now we'll talk about particle and antiparticle annihilation, and we'll draw the Feynman diagram to calculate the amount of energy released. For example, in this diagram, you see an electron, and a positron. They annihilate to form energy. Energy and mass, they are interchangeable. So here in this case, the particle and the antiparticle, they annihilate to form energy. We could calculate the total energy of the electron and the positron before they annihilate. So let's start calculating the total energy. So this other diagram explains that energy can be changed into mass, and here you have mass or particle and an antiparticle changing into energy. So you see the total energy of the electron-positron system before they collide. So we have the electron and the positron system before they collide. That will be the kinetic energy added to mc squared of each. So that brings us to this equation. Total energy is twice, within parentheses, mc squared plus the kinetic energy, mc squared for each and the kinetic energy of each. And this is changing to energy. So we will use the formula E equals to hc over lambda to calculate the wavelength of energy released. And so you make wavelength as the subject, and this is how you get the expression for the wavelength of the energy released. You could try solving a mathematical problem using this equation. Now let's try to analyze the physics of a nuclear bomb. Once the target is narrowed down, the bomb is dropped. The fusing system is designed to trigger at the most destructive altitude, which is approximately 1,500 feet. When the radar altimeter senses the correct height, the firing switch closes. This ignites the 3 gun primers, which detonates the 6-cell powered bags. This launches a uranium projectile towards the opposite end of the gun barrel with a muzzle velocity of 300 meters per second. Approximately 10 milliseconds later, the nuclear fission chain reaction starts. In this radioactive decay process, a neutron is fired onto a uranium-235, and the uranium splits into 2 daughter nuclei and 3 neutrons. A chain reaction occurs, and this releases gamma photons and large amount of energy. This creates a massive explosion, forming a mushroom cloud and releasing radiation into the atmosphere. The explosion also produces intense heat and blinding light. Whether the bomb exploded at Trinity site was the first one. When a student at Rochester University, Charles Berlitz, asked Oppenheimer whether the bomb exploded at the Trinity site was the first one to be detonated, to which Oppenheimer answered, "Well, yes, in modern times, of course." Why did Oppenheimer say yes, in modern times, of course? Why did Oppenheimer quote from Bhagavad Gita when he saw a nuclear explosion? Many believe that the war reference in Bhagavad Gita was an atomic war that took place thousands of years ago. Hindu texts stating from thousands of years ago seem to suggest that some kind of highly advanced weapon resembling an atomic bomb, was set off on this earth some 12,000 years ago. A single projectile charged with all the power, called Brahmastra, an incandescent column of smoke and flames as bright as 10,000 suns, rose in all its splendor. It was an unknown weapon, an iron thunderbolt, a gigantic messenger of death, which reduced to ashes an entire race. Many of the descriptions of these battles within the text speak of devastating weapons having the power of the sun and striking down huge areas of land. They also mention huge death toll similar to that and those found with a nuclear weapon. In 1920, the ancient city of Mohenjo-daro was rediscovered. Archaeologists believe that 35,000 people once lived in this city. However, it is still debated how this ancient city came to an abrupt end. Only under 50 skeletons have been discovered in the city, many appearing scattered and oddly positioned, suggesting that they had endured an unexpected and rough passing. Yet for many, the fall of Mohenjo-daro is still a mystery. Experimental analysis showed that the Mohenjo-daro rock contained mostly silicon, aluminum, and some calcium and potassium. X-ray diffraction is able to exactly determine how a material was formed. The composition was very similar to volcanic rocks. Well, this is only possible by subjecting the clay to a very high temperature. We are talking about 4,000 to 5,000 Fahrenheit. This has to be something supernatural. So, did our ancestors possess nuclear weapons? Well, regardless of the evidence, we are not for certain that our ancestors possess nuclear weapons. However, we cannot deny that something strange happened years back. As technology further develops and further artifacts are discovered, maybe the truth will be apparent to all. It's important to know where we are coming from. Then only we will appreciate where we are going. Bhagavad Gita has been extensively used in the Indian courts as a tool to force people speak the truth. It's time to include certain aspects of Bhagavad Gita in the curriculum and allow students to explore the truth. Thank you, ladies and gentlemen. I hope you all enjoyed this presentation. Luckily, today is Janmashtami, Lord Krishna's birthday. Wishing you all a very happy Janmashtami from London. May the blessings of Lord Krishna always be with us. Thank you and have a lovely time.